Okay, let's unpack this. Welcome to the deep dive. If you're navigating the world of cloud computing right now, you already know how incredibly fast things move.
Oh, yeah. It's almost hard to keep up.
It really is. So today, we have a fantastic mission. We are looking at the Google Cloud Platform Technology Nuggets, the updates from late February 2026.
Some really big updates in there.
Huge. And our goal today is simple. We're going to cut through the noise, skip the overwhelming technical jargon, and highlight exactly what these new rollouts mean for you, the practitioner.
Right.
Whether you're prepping to build a new architecture or, just trying to keep your skills sharp, we've got you covered. And because the cloud world is practically swimming in acronyms.
That's the whole alphabet soup.
Exactly. We are going to make sure we briefly unpack what each tool actually does as we go. That way, whether you're a beginner or an intermediate user, nobody gets left behind.
I love that approach. It's great to be here. And we really do have some massive themes to explore today. We're seeing AI models getting noticeably smarter, but more importantly, more resource efficient.
Yeah, doing more with less.
Exactly. We're also seeing enterprise data becoming almost conversational, meaning it's radically easier to interact with your databases than ever before. And we're going to look at some massive physical infrastructure investments Google is making literally under the ocean to keep all this running. It's a really transformative time for the platform.
It really is. So let's jump right into the AI side of things, because that late February release had some major updates for Vertex AI.
Yeah, that was front and center.
For anyone who hasn't spent much time there yet, Vertex AI is Google Cloud's fully managed machine learning platform. You can think of it as the central workshop where developers can build, train, deploy, and scale their AI models all in one place.
A one-stop shop.
Right. And the big headline here is the preview of Gemini 3.1 Pro. Now, looking at the performance specs, they are citing a 15% improvement specifically in complex tasks. We're talking about 3D transformations, rotation order logic, and grounded reasoning across both structured tables and unstructured data. But I have to play devil's advocate for a second.
Go for it.
In the grand scheme of AI leaps, is a 15% bump in complex logic really that groundbreaking for the average practitioner?
Well, what's fascinating here is why this matters to you when you are actually footing the cloud bill. Yes, the 15% boost in handling complex reasoning is great if you're building highly sophisticated tools.
Right.
But the real headline for developers isn't just the raw intelligence, it's the efficiency. Gemini 3.1 Pro is generating fewer output tokens while maintaining that high reliability.
So it gets to the point faster.
Exactly. And in the cloud world, fewer tokens directly translate to lower costs and faster response times. You're getting a smarter model that is actually cheaper and more efficient to run at scale.
Which is huge.
It tackles that classic problem we've seen over the last few years where AI models just become too bloated and expensive as they get smarter. If you're a startup dealing with runaway cloud costs, that efficiency gain is everything.
That makes a lot of sense. Better performance, lower overhead. Now, the other model that caught my eye in this Vertex AI rollout is something called Nano Banana 2.
I know, the name is...
It's a quirky name, let's be honest. But the practical applications are incredibly serious. Historically, getting an AI to generate an image with perfectly spelled text inside it has been an absolute nightmare.
Oh, it's the classic spelling problem in AI generation. It's always just a garbled mess.
Exactly.
Usually, developers have had to build these complex workarounds, generating an image, finding the blank space, and using a completely separate text rendering pipeline to overlay the words just to create a simple banner ad.
Right. But Nano Banana 2 is apparently fixing this natively. It does accurate text rendering directly into the generated images. Plus, it features high-resolution upscaling to 2K and 4K and native support for multiple aspect ratios, like 16.9 for your standard desktop screens and 9.16 for mobile video formats.
This is a massive leap for anyone building media-rich applications or marketing automation tools on Google Cloud.
Yeah.
That native aspect ratio support alone means developers can spend significantly less time cropping, formatting, and adjusting outputs, and more time actually building core features.
That flexibility is great, but, models are only as good as the infrastructure running them. Which brings us to another Vertex AI update provisioned throughput.
Right.
Essentially, this is a feature that allows you to reserve dedicated computing resources so you can guarantee capacity and performance for your applications. But what really surprised me is what you can run on it.
The external support.
Yes. They are rolling out support for Anthropic models, as well as open source models like Llama 4, Qwen 3, GLM 4.7, and DeepSeek OCR. I have to ask, if Google has Gemini, why are they making it so easy to run Llama 4 and Anthropic on Vertex AI? Isn't that just cannibalizing their own product?
If we connect this to the bigger picture, it shows exactly how Google Cloud is adapting to the reality of enterprise tech. They realize they cannot build a walled garden.
Right.
By allowing you to reserve dedicated enterprise-grade infrastructure for external models like Llama 4 or Anthropic, they are actively embracing an open ecosystem. For a cloud practitioner, flexibility is absolutely everything.
And you want to be locked in.
Exactly. You might have one pipeline where Gemini is perfect and another specific use case where an open-source model is heavily optimized. Google Cloud strategy is to say, whatever model you choose, we want you running it on our reliable infrastructure.
That is exactly what practitioners want to hear. Nobody wants to be tied to a single vendor's model if the industry suddenly pivots. Okay, here's where it gets really interesting. Let's transition over to the data side of the house.
The Google Data Cloud updates.
Yes, specifically how they are making data talk. The big update here revolves around Managed Model Context Protocol, or MCP servers. But to truly understand why MCP is a game changer, we need to quickly look at the databases it supports.
Let's walk through them because the breadth of integration here is what makes it so powerful.
Right. So imagine you're running a massive global e-commerce platform. You might be using AlloyDB, which is a fully managed PostgreSQL-compatible database designed for your absolute top-tier enterprise transactional workloads. But for your global inventory, where you absolutely cannot double sell an item across continents, you're likely using Spanner. Spanner is Google's globally distributed relational database, famous for handling massive scale with perfect consistency.
And for standard relational data, you might just be relying on Cloud SQL, which is their fully managed service for MySQL, PostgreSQL, and SQL Server.
Exactly. Then for the mobile app side of your e-commerce platform, you'd probably use Firestore. That's a serverless NoSQL document database that syncs data in real time.
Yeah.
And finally, for your massive analytics and telemetry workloads, like tracking every single click on the website, you'd use Bigtable. Bigtable is a fully managed, wide-column NoSQL database built to handle massive throughput with incredibly low latency.
So you have this incredibly diverse, complex web of databases. Now let's explain the so what of this model context protocol. Traditionally, if you want an AI agent to answer a simple question like, are we low on inventory for this specific shoe? A developer had to build custom glue code to connect the AI to Spanner, and then completely separate custom code to connect to Cloud SQL or Firestore. It was tedious, brittle, and highly prone to breaking. MCP completely changes that paradigm.
How so?
It provides a standard, universal interface for AI agents to connect directly to your operational data across all of those databases we just listed. And it does this without the developer having to build or manage any new integration infrastructure.
It's essentially a universal adapter for your AI, but giving an AI agent direct access to your Spanner and AlloyDB databases sounds like a security nightmare waiting to happen.
It would be if it weren't natively integrated with Google's security stack. The update specifically highlights that Managed MCP uses Identity and Access Management, or IAM, for strict authentication.
Oh, nice.
And it logs everything through Cloud Audit Logs. So you aren't just giving an AI the master keys to the kingdom, you are strictly controlling its permissions, and you have a complete auditable trail of exactly what data the AI agent is interacting with.
Okay, that definitely lowers the blood pressure for the security teams out there. Now, keeping with this theme of making data more accessible, let's talk about BigQuery.
The powerhouse.
For anyone new to it, BigQuery is Google Cloud's serverless, highly scalable enterprise data warehouse. It is where you dump petabytes of data to run massive analytical queries. The massive news here is something called autonomous embedding generation.
This is one of those updates that sounds highly technical, but solves a painfully human problem.
Right. To use an analogy, an embedding is basically a way of translating human data like a text description of a product into a series of numbers or vectors that an AI model can instantly understand and compare. Previously, translating that data was a major chore.
A massive chore. If you had data sitting in your warehouse, you had to build manual, messy data pipelines. You'd have to trigger an Airflow job or a cron job to detect new data, call an external embedding model, wait for the translation, and synchronize the new data back to the database.
Which is just fragile.
Pipelines break, data drifts, and it becomes a huge maintenance headache. With autonomous embedding generation, you can now define an embedding column directly in a BigQuery table using a simple SQL command. BigQuery handles the entire translation process in the background, continuously syncing with Vertex AI models.
It's like having a dedicated translation department working in the background 24/7 without you having to manage their shifts.
Exactly.
And the update also mentioned a new function called AI.search. This lets developers perform vector searches directly on this data to find similar items without having to manually configure the underlying search models. It makes building retrieval augmented generation, or RJ applications, vastly simpler.
And speaking of simplifying things, we have to look at the new Conversational Analytics API in BigQuery. This allows developers to build agents that literally talk to BigQuery using natural language. Think about a SaaS product where you have non-technical business users staring at dynamic reports.
I've been that person. You look at a chart and you immediately have a follow-up question, like, what did these sales look like specifically in the Midwest last quarter?
Exactly. And traditionally what happens, you have to file a ticket with the data engineering team, wait 3 days, and hope they write the correct SQL query to filter that data for you.
A worst.
With the Conversational Analytics API, developers can enable that non-technical user to just type their follow-up question in plain English. The AI understands the context, generates the necessary SQL query behind the scenes, and produces the new real-time visualization automatically. It drastically reduces the bottleneck between data engineers and business users.
That is a massive productivity unlock. Just to wrap up this data section quickly, there is a brief but crucial mention of the Spanner columnar engine, which is now in preview. What this does is allow users to serve Apache Iceberg Lakehouse data with very low latency. In practical terms, it's adding a new way to store and read data within Spanner so that complex, heavy analytical queries run incredibly fast on your live operational data. And it does this without slowing down the actual transactional system.
It is a phenomenal update for anyone trying to run real-time analytics. You no longer have to export your transactional data to a completely separate system just to analyze it without crashing your live application.
Exactly. All right, moving on, I want to pose a question to you, the listener. Let's say you are building a customer service chatbot on Google Cloud Platform. How do you actually make it remember anything?
That's the million-dollar question.
If a user talks to it on a Tuesday and then comes back on a Friday, how does the bot recall the context of that previous conversation? The February updates break down this fascinating polyglot persistence architecture. Polyglot literally meaning many languages, or in our context, many databases. Let's break down the layers of this memory system.
Memory is absolutely critical for a reliable agent experience. A bot with amnesia is just a frustration engine.
So true. So for short-term context, the immediate active back and forth of a live conversation, the architecture relies on memory store for Redis. For those unfamiliar, memory store is an in-memory data store. Because it holds data in the system's memory rather than on a traditional disk, the retrieval time is practically instantaneous.
Which is exactly what you need for an active session.
Yeah.
But you can't keep everything in memory forever.
Right. So for midterm memory, which acts as the system of record for the user's complete chat history, the architecture moves the data to Bigtable. As we defined earlier, that is the massive, low-latency NoSQL database, perfect for heavy throughput.
And then for long-term analytical archiving, where you want to analyze thousands of chat logs to look for trends, it moves the data into BigQuery.
And what happens if a user uploads a picture of a broken product or an audio clip? The architecture uses cloud storage, which is Google's highly durable object storage service designed specifically for holding unstructured data like media files.
And to seamlessly orchestrate the movement of all this data between those different storage layers, the system relies on PubSub, which is GCP's asynchronous messaging service that decouples senders and receivers.
Alongside Dataflow.
Yes, Dataflow, which is their streaming analytics service for processing data pipelines in real time.
It really puts into perspective how much invisible architecture goes into a simple hello again from a chatbot.
If we connect this to the bigger picture, it highlights a fundamental truth about cloud engineering right now. Building a prototype AI that can generate a clever response is relatively easy. Making that AI reliable, robust, and capable of maintaining state over a long period of time in a production environment is incredibly difficult.
Which is why the updates explicitly state that developers have to move past subjective vibe checks.
Vibe checks.
Yeah, vibe checks. The old habit of chatting with your bot for 5 minutes and saying, yeah, the vibe feels right, let's deploy it.
You can't scale a vibe check. The documentation stresses the absolute necessity of shifting to a disciplined continuous evaluation, or CE, framework, where you are constantly running automated tests against your agent's responses.
That is a critical maturity step for the industry. Now, part of building a reliable agent is also ensuring it is secure. The updates reference the recent Cloud CISO Perspectives report. Just to be clear, we are simply reporting what's in the document here, but it outlines some serious ways that threat actors are utilizing AI.
It's pretty alarming stuff.
The report detailed model extraction attacks, where adversaries use techniques like knowledge dissolution to systematically probe an AI until they can basically steal a company's underlying intellectual property and training data. It also noted that certain government-backed groups are actively utilizing large language models to accelerate their reconnaissance, write malicious code, and scale up social engineering campaigns.
It is the sobering reality of the current threat landscape. As the tools get more powerful, so do the adversaries. But the report also outlines the defense strategy. To counter these automated high-speed threats, Google Cloud is deploying what they call agentic security operations.
Agentic security, meaning agents fighting agents.
Essentially, yes. They're automating threat hunting and alert triaging. Instead of a human security analyst sitting in a dark room manually sifting through 10,000 suspicious alerts to find the one genuine attack, Google is deploying specialized AI agents to analyze the network patterns, triage the noise, and respond to active threats at machine speed.
Fighting fire with fire.
Exactly. It is utilizing AI to scale your defensive capabilities.
That makes a lot of sense. You definitely want AI on defense if it's being actively used on offense. Okay, we've talked about all these amazing features and architectures, but how do practitioners actually get started without getting overwhelmed? The rollout included a mention of a newly published guide specifically focused on moving from prototyping in Google AI Studio directly to full production on GCP.
This is a crucial gap to bridge. AI Studio is fantastic because it's so easy to use, or many developers start playing with models there.
Right.
But when you need to handle real-world user traffic, manage load balancing, and ensure uptime, you need enterprise infrastructure.
Exactly. And the guide explains how to migrate those prototypes to tools like Cloud Run and Compute Engine. For our quick definitions, Cloud Run is a serverless container platform. It lets you write your code in any language, put it in a container, and Google handles all the server provisioning and scaling automatically.
Super hands-off.
And Compute Engine, on the other hand, gives you highly customizable virtual machines. It's for when you need absolute control over the operating system, the hardware, and the specific network configurations.
And for listeners who want to get hands-on but are worried about costs, the rollout heavily highlights the Google Cloud free tier. It includes $300 in free credits and ongoing monthly usage limits.
It's a brilliant sandbox.
It really is.
Yeah.
Beginners can experiment with deploying models like Gemini 3 Pro Image, hosting applications on Cloud Run, and querying datasets in BigQuery without burning a hole in their personal or corporate wallets.
It's the perfect place to break things safely. Now, on the infrastructure and tooling side, another fascinating product update is around EventArc Advanced. EventArc is a serverless eventing platform. You can think of it as the central nervous system for your cloud architecture, routing events and triggers from one service to another.
Right.
What is really clever about this new advanced version is its two-layer model. It splits the platform into a bus layer and a pipeline layer.
It is a very elegant solution to a common corporate bottleneck. It separates the concerns between security and development. The bus layer is strictly for the platform administrators or SecOps teams.
Okay.
They can enforce centralized security rules globally at this layer-like implementing identity and access management policies or VPC service controls, which creates secure, invisible perimeters around your cloud resources to prevent data exfiltration.
And then you have the pipeline layer.
Precisely. The pipeline layer is purely for the developers to write their integration logic, route the events, and transform the data. It completely removes the friction. Security teams are happy because the underlying environment is locked down at the bus layer.
And developers are happy because they have the freedom to build their logic in the pipeline layer without constantly tripping over security hurdles or waiting for approvals.
Exactly. That is going to save a lot of arguments between departments.
The updates also briefly highlighted a very cool integration for our database fans out there, the Neo4j Gemini CLI extension. Neo4j is a hugely popular graph database used for mapping complex relationships. Now, let's be honest, almost nobody actually enjoys writing cipher queries, which is the specific language used for Neo4j from scratch. It can be incredibly tedious.
It certainly has a steep learning curve.
Well, this new command line interface extension uses that model context protocol we discussed earlier. It allows developers to use their terminal environment to convert natural language directly into cipher
Oh,
queries.
that's incredibly useful.
You just type what you want to find in plain English, and the AI generates the precise query. Again, it is all about lowering the barrier to entry and reducing developer friction.
And while we are talking about frictionless cloud computing, we can't forget that all of this digital magic ultimately relies on heavy physical hardware. The latest nuggets brought up the America-India Connect initiative.
Yes, this is a massive $15 billion investment in global network infrastructure. The project establishes a brand new international subsea gateway in Visakhapatnam, often called Vizag in India, and it adds 3 new massive subsea cable paths connecting India directly to Singapore, South Africa, and Australia.
It's incredible.
It's a great reminder that the cloud isn't actually in the sky. It's composed of highly advanced, heavily armored physical cables sitting at the bottom of the ocean.
It is scale on a level that is hard to comprehend. And for listeners who want to get hands-on and start building the architectures that run on those cables, Google has published a new series of technical guides for developing production-ready AI agents.
Those are great resources.
They cover everything from a basic introduction to agents to deep dives on tools and interoperability using MCP and advanced context engineering. That is the absolute best next step for any practitioner looking to level up their skills after listening today.
Excellent recommendation. Okay, we have covered a massive amount of ground today. We looked at the critical token efficiency and complex reasoning gains of Gemini 3.1 Pro and how Nano Banana 2 solves the AI image spelling problem natively.
Big wins.
We explored how the Model Context Protocol is acting as a universal adapter for AlloyDB, Spanner, and Cloud SQL. We discussed BigQuery's autonomous embedding generation, which is finally killing the need for messy manual translation pipelines.
Thank goodness.
We broke down the polyglot persistence architecture needed to give chatbots reliable, long-term memory across Memory Store and Bigtable, and we looked at how agentic security is automating threat hunting. So what does this all mean? The big takeaway from the February rollouts is that Google Cloud Platform is heavily focused on removing the friction from building AI agents. They are actively making them cheaper to run, easier to securely connect to your databases, and robust enough to deploy in a real-world production environment without relying on vibe checks.
It truly is a paradigm shift in how we build applications. And this raises an important question, something for you, the listener, to mull over as you go about your week.
Let's hear it.
We are seeing tools like BigQuery autonomously generating data embeddings in the background without human intervention. We're seeing AI agents securely querying half a dozen different databases simultaneously using standard MCP protocols. The underlying infrastructure is becoming highly automated and incredibly self-sufficient. At what point does your job as a cloud practitioner fundamentally shift from actively writing the integration code to simply managing a team of specialized AI agents?
Oh, wow.
If the agents are writing the SQL queries, syncing the data pipelines, and actively hunting network threats, are we moving away from being cloud developers and stepping into the role of cloud managers?
That is a fascinating thought to end on. Managing a team of digital agents instead of writing the scripts yourself. The entire landscape of what it means to be a practitioner is definitely shifting fast. Well, that is all the time we have for today. Thank you so much for joining us on this deep dive into the Google Cloud Platform updates. Be sure to check out those production-ready AI guides we mentioned to get some hands-on experience with these new tools in the free tier. Keep learning, keep experimenting, and we will catch you on the next deep dive. Take care.